In this video, I will explain the experiment results and some analysis regarding the effect of wind velocity towards drag force. Since the force is related to the displacement of the rubber band by the rubber stiffness, the rubber stiffness must first be found. To do so, the rubber band is hooked to the spring Newton meter. The end of the hook is initially positioned at the ruler 0, and then the Newton meter is pulled until the displacement is approximately 10 centimeters. According to Newton's first law, the force reading in the Newton meter is the force exerted by the rubber. And since we know the force, the rubber stiffness can be calculated using Hooke's law. To find the rubber stiffness, the measurement is done repeatedly up to 10 trials. Here is the data of all the 10 trials. And as I mentioned before, the displacement is 10 cm or 100 mm. Using the Hooke's law, with F, the rubber force, equals to K, which is the rubber stiffness, times the X, which is the displacement. Thus, K is equal to F over X. In this case, the K is equal to 0.0193 Newton per millimeter. Moving on, now we're into the real experiment results. For the first case, which is the low wind velocity, for the wind velocity, I use 5 readings of the anemometer, starting from when the anemometer reading is about steady. For the rubber band displacement, I use single measurement, and for this case, the rubber band displacement is 3 mm. Doing the drag force calculation using the Hooke's law once again, it is found that the drag force for this case is 0.0579 Newton. The same method applies for the next two cases. For the case of medium wind velocity, the average wind velocity is around 12.42 meters per second, and the rubber band displacement is about 5 mm. So, performing the drag force calculation, it is found that the drag force is around 0.0965 Newton. And finally, for the third case, which is the high wind velocity, the average wind velocity is 17.54 meters per second, and the rubber band displacement is 8 millimeters. So the drag force is found to be 0.1544 Newton. Plotting between the drag force versus velocity, this is the plot. Now, as a discussion, we're going to compare that experiment result with the theoretical relationship between the velocity and drag force. According to theory, the formula is F drag equals to half rho v squared CdA, where the drag force is indicated by the F drag and the wind velocity in here is v. So we can see that the relationship is actually quadratic, and the plot would look something like this. Now if we compare side by side between the theoretical and experiment, this is the plot of theoretical that we see earlier, and this is the experiment result. It can be seen that both actually shows that the drag force increases as the velocity increases. However, the trend is slightly different. So, as I mentioned before, both theoretical and experiment results show that the drag force increases as the wind velocity increases. However, the shape of the curves between theoretical and experiment are slightly different due to errors during experiment. For possible errors, first, since the wind measurement and the force measurement were done separately instead of simultaneously, there may be some difference in the wind condition between the two measurements, or in other words, the wind used for the force measurement may not be exactly the same as the one that is measured by the anemometer. Second possible error is the friction between the clamp and the rope, which will make the force equation at the rubber is actually not purely from the drag force itself. Third possible error is friction and rolling resistance between the table and the tires of toy car. This effect is similar to the previous error. And finally, human error during measurement, which can be in the form of error in handling the instruments, for example, a shaky hands when holding the rulers, or when holding the pump or the compressor nozzle, and also parallax error when measuring the displacement using the ruler, and many other possible errors. So, to conclude, the experiment shows that drag force increases as the velocity increases, although the trend cannot be exactly shown from the experiment itself. Possible errors include experiment conditions, such as the friction and the wind condition, and human errors. So this is the end of my experiment. So thank you for watching and have a great day.